Let me share my screen.
Yeah.
Oh, when you're able to see,
Ah,
please let
yes,
me know.
yes, yes.
So, means in a theory part we discussed, we need to define the boundaries, we need to define authentication and authorization, am I
Ah,
right?
yes.
And we need to find a trust, means between components and how we can make a secure thing. So we
Ah,
discuss all these things now. Today we will discuss the how part.
right.
So why how part is important, because with the help of how part you will get whatever you learn, how you can implement those things.
Ah,
Am
ah,
I
ah.
right?
Yes, yes, yes.
So we will go step by step on this,
Ah,
and what things are required, what is thing need to be take care for how
hmm, hmm,
part.
hmm, hmm, hmm.
So first, because we earlier we discussed about these things.
Ah,
So first we talk about boundary,
ah, right,
how to identify.
right.
So for boundaries, first we need to identify a means starting point or entry
Ah,
point.
ah, ah,
Means
ah,
from where user is able to interact, or
ah.
from how developer able to interact, or
Right, right.
means how means third API need to be called. Am I
Hmm.
right? What is the
Ah,
use?
hmm, hmm, hmm,
So all thing means it's not about front end only. Even though
hmm.
whatever we are using internally, that's also need to be defined means entry point.
Ah, ah, ah,
Because if you know the entry point, then you can define the, you can say, hey, what data is exchanging,
ah.
and what is how it's moving.
Hmm,
Am I
hmm, hmm.
right?
Right.
So here we are identifying means where they were request data or command enter a system. You
Ah,
understand my point?
ah,
So
ah, ah.
uh, if there is a application front end is there, from there we are have a user is able to interact with our application. Am I
Hmm,
right?
hmm, 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 hmm.
And sometime external API we will expose on this only. We will
Ah,
provide a UI, but internally we are calling that
ah,
external API.
ah, 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 ah.
So that time we are doing, means from backend side
Okay.
we are doing that. Am I right?
Ah, ah, yes,
So,
yes.
and for this means creating a badge of those sport tools. So means we need to know
Ah,
entry point first.
yeah, right.
Entry point is a possible trust boundary. First,
Hmm,
we will
hmm.
need to create a trust at a entry point
Right,
level only.
right.
That's why means every company, every you can say have a, you can say, first security check is there. Even
Okay.
society itself,
Ah, ah,
housing
ah,
societies are there.
ah,
So there they will have a security guards, which
ah, ah,
which will take approval
ah,
from
yes.
us.
Right.
Hey, this is a, you can say, valid. You need to approve this visitor.
Hmm,
He
hmm, hmm, hmm.
he or she is claiming he's a means he's visit your house.
Hmm,
Are
hmm,
you
hmm.
going to approve? So this is one security check, and another security check on our tower itself.
Ah, ah,
A
right.
tower guard also called us. Hey, you have a delivery, or you want to approve or disapprove.
Hmm.
So same way for trust, we need to define a boundary.
Okay.
So here means what, now question arise, what system can trust and what cannot trust.
Hmm, 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 hmm.
You understand my point?
Right. Yeah, yeah,
Means
correct. Hmm.
there should be some metric should be there, based on that we can say, hey, this is trustworthy, this is not trustworthy.
Yeah, right,
Am I right?
right.
Sometime we got a call from person who will not ordered anything. We are not expecting anyone, and
Mm-hmm.
sometimes we will got approval by
Yeah,
mistake. Or
mm,
so for that we cannot entertain those. We
correct,
will
correct.
reject those.
Ah,
So
ah,
for
ah.
that, here itself we need to decide: can
Mm,
we trust
mm.
or can't
Not,
trust?
yes, yes.
So here client input is untrusted because on a UI, user can enter
Ah,
anything because we
yes,
are not
correct.
going to stop. But whatever system we are going, so we can means make a system in that manner.
Right.
When things are, we can apply validation.
Ah, 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 ah.
We can, you can say, apply a validation there. With the help of that, we can check
Right,
before hitting anything, before
right,
making a big call or anything. We can check that. And
right,
apart from
right.
that, whatever extra information we require,
Ah,
header from outside are untrusted. If
okay.
someone is, you can say, we requesting us something, and they are providing extra information to us,
Right.
which is also a, you can say, untrusted thing,
Ah,
which
ah,
is
ah,
not
ah.
required. And in this manner means you can think
Mm,
of whatever thing harm us or is a dangerous
mm.
us. We need to think on those points and write down
Right,
those points, and
right,
then we will means move ahead and take care of those whatever you identified. Here they mention these five things:
ah, ah.
identify untrusted unless verified.
Yeah, correct.
Okay, claimed user role is untrusted unless enforced.
Untrusted, untrusted,
Yes.
server side. Uh, 1 minute. Claimed user role is untrusted unless enforced service side. 1 minute, Deepak. Okay, the claimed user is untrusted. Okay, unless, oh, right, right. Okay, fine. That's enforcement server side. Okay,
You
right,
can
okay.
go ahead and
Ah, ah,
I
ah.
will give my input.
Okay, fine. Okay, fine. Okay. Okay, the whichever user the claimed user is untrusted unless enforced from the enforced server side. Enforced that word enforced server side. Can you just brief me on that?
So in a server side, we will enforce means here
Ah,
you need to claim that if you are claiming you are authorized user, his role is untrusted
ah,
unless enforced server side. We need to do that. We need to
mm.
validate that. Let's say
Okay.
user,
Ah,
we will give a permission to the user to check our website. But if he
ah,
want to access, you can say, other services. Let's say
ah,
he want to purchase our course or purchase
ah,
our boutique product. Then he
ah,
need
ah.
to claim. That means he need to log in with us.
Okay. 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 Okay.
Okay.
Okay. Got it. Got it. Okay.
Okay. Go ahead, and we will discuss each and every point step.
Fine. Fine. Mark boundary crossings. Fine. A trust boundary exists whenever trust level changes, such as public internet. Oh, okay. API gateway. Right. Okay. Okay. User browser backend. Internal services. Another service. Third party callback platform. Admin dashboard. Production operation. Okay. Mark boundaries crossings. Okay. Mark boundary crossing in architecture. Okay. So whenever you go to public internet, yes. The trust body exists whenever trust level changes is okay, fine. Internet API gateway, user browser, backend, internal server, okay, another service is calling, third party callback platform, yes, admin dashboard, production operations, okay, multiple crossings in boundary crossing in architecture, okay, fine, okay,
So
whenever,
here, yes,
huh,
here you are defining an entry point, and after crossing entry, who will host,
huh,
that and attend the guest. Am I right? Or
okay,
user. So you are defining that as well. Entry is fine, but
mm-hmm.
you need to define the host as well.
Huh, 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 huh.
Am
Okay,
I right?
Right, right, right. Okay. Fine. Then define security controls at each boundary. Okay, each boundary specify authentication, authorization, input validation, rate limiting, encryption, auditing, replay protection if needed. Okay, yeah, this is what is and security control each boundary. Fine. At authentication level, authorization level, input validation, rate limiting, encryption level, auditing, then replay protection if needed. Okay, fine. Yeah, this is clear.
Yes, which we discussed earlier as well.
Earlier.
Means
Hmm.
yes, means even though you will means user is enter to our building, am I
Ah,
right?
ah,
But we cannot give access to all the building.
yes, yes,
Means
yes.
user have a means authorize for some of the parts of the building. We cannot give a means if he or she
ah,
require a access on a
ah.
different part, then he need to apply a request. Then
Oh,
he can get there, get
oh, okay.
permission. Then he can go there.
Oh,
Until
oh,
unless if we don't have access, he cannot. So you cannot think means if you apply a authorization or means this authentication on a one part, it's done. No, we need to define the boundary in an internal part as well.
oh, okay, okay,
You can
okay.
you can think of means in a company
Ah,
we have a you can say server or data center is there
ah,
in means yes. So in that means where this data center is situated, we
ah.
means normal employee don't have entry there. Am I right?
Okay, okay.
So if even though you are authorized and you have a card there, but
Ah,
that floor is that you can say floor is restricted for you. You cannot go there.
right. Yes, yes, yes,
You
yes,
understand my point?
yes, yeah,
So,
yeah.
so same thing is applicable here.
Ah,
Means while you are hitting another API
ah,
or touching a you can say if that's a you can say yeah, under this trust boundary, then you need to apply all these things there as well.
ah.
You understand my point?
Okay, 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 okay. Then never assume internal means, yeah, correct, safe. Never assume internal means safe, right? Internal traffic must still be validated. Many security incidents happen because systems trust internal calls blindly, but perfect. Yes,
Which I told you.
yes, yes, yes. Right. Beautiful. Then food delivery example. A mobile app calling order API crosses a trust boundary when this is sorry crosses a trust boundary. The system must verify the user token, validate the payload, check ownership of the order, restrict access to only allowed operations. Yes. Okay. Perfect. Yes. How to implement? Yeah, very important part. How the whole part of it. Decide who needs identity verification, authentication needed for customers, delivery partners, restaurant operators, admin users, internal services, then partner systems. Perfect. Okay, so decide first who needs our identity verification. Fine. Now, step two, choose the right authentication method. Okay, like customer login session or token based. Oh, okay, fine. Service to service calls, short-lived service tokens, or MTLS. MTLS is multi-transactional. MTLS
No. Transfer layer security.
layer system. Oh, layer. Okay, okay, okay. Multi transfer layer security. Okay, fine. Then third-party API access, signed keys or OAuth. Okay. Admin access, strong authentication, often MFA, multi.
Multi-factor
That's
authentication.
authentication. Okay, MFA. So choose the right authentication methods. One is customer login, either the session based or token based. Service called short-lived service token or MTLS. Third-party API, signed keys or OAuth. Admin access, strong authentication, often multiplayer. Okay, fine, got it. Correct.
So MFA means where they will send a code to us. Am I
You
right? With
enter
the
it.
help of
Then
that
verify. Okay, fine. Okay, okay.
OTP they will send to us.
OTP. Yes, yes, yes,
Or you
yes.
can say we have a app,
Ah,
authenticator app of
ah,
Microsoft and another company.
ah,
they
ah,
will send the things there.
ah,
Am
ah.
I right?
Yes.
So these are things we need to consider, because if someone get access of admin, they can do lot of things.
Ah,
Am I
yeah, yeah.
right?
They can do anything. Okay. Correct.
Okay,
Mm,
so that's why it's
fine.
a crucial. So we need to special take care of that.
Yes, yes.
Nowadays, if you check this, Google and they also apply this.
Multi-factor authentication. Yes.
Okay, so
Right.
when you log in on a new device or
Yes,
new
they have.
place,
Correct. Correct.
okay, they will take care of this,
Correct. Correct.
and they forcefully say, "Hey, you need to do this. You
No,
are
correct.
not
Yes. You know,
you not apply this, but you
yeah.
need to apply this." Okay, go ahead.
Okay. Valid identity boundary. Okay, fine. Identity should be verified before a request is trusted. An identity should be verified before a request is trusted further into the system. Like checks may include token signature, token expiry, issuer verification, audience verification, session validity, certificate identity for service. Yeah, correct. Validate the identity at the boundary. Yeah, correct. Okay, fine. Okay. So this is checks we may include token signature, token expiry, expires, issuer verification. Okay. Oh, issuer verification also is done. Oh, okay, okay. The audience verification. Okay. The session validity. Okay. The certificate and identity for okay, Deepak. Yes. Yeah.
So, means for session validity or thing means everything should be time bounded. We
Time bound.
cannot we cannot say means, hey, if this is a user login and try to make a payment, means
Ah,
payment gateway is you can say always open, he can do that. No,
ah, ah,
because think of means how you can say this hack our services. So
ah,
what
ah,
they will do,
ah,
they means like these banking site, what they will do means if
ah.
you log in
Hmm.
for a session, they store your information
Information. Yes. Ah,
in a cookies or session. And during that
yes.
session, if you try again
Ah,
with
ah,
for payment and thing, they will
ah,
not. Not talking about all the sites. I am talking
ah.
about some of the sites.
Some of the sites. Okay. Okay.
Okay, so they
Okay.
will just they will not ask the things again and again to user. They will
Hmm.
take the thing from a session only.
Correct. Right.
Okay.
Ah,
Meanwhile, if someone you can say give us some means we got a you can say email from someone or message from someone with a link.
ah,
Okay,
ah, ah, ah,
and if
ah,
you click on that link under the
ah,
hood, maybe they are calling your bank
ah, ah, ah,
this and for a transaction.
ah, ah, ah,
Okay, because you already have that this when you click on that, your money is detected.
okay, okay, okay. Yes, it is happening. Many cases are there. Many cases are there. Okay.
So you understand. So that's
Yes.
why we need to define this
Uh,
expiry, validity.
yes. Okay.
You understand my point?
Right, right, right.
Means in this manner, we can bank sites or company site can check
Ah.
or give a message pop-up to the user. Hey, we will
Mm.
get this. Have you initiated this by your own or someone initiated
Someone else.
on your bill?
Okay. Okay.
You understand my point?
Yeah, yeah,
So
yeah. Right.
these things are required.
Right, right. Okay, you short-lived credentials. Yeah, correct. Short-lived tokens will reduce the risk if credentials are leaked. Yeah, correct. The short-lived risk. Perfect. Yes, right. Then do not store or transit secrets, yeah, insecurely. Keep credentials encrypted, rotated, store in secret management systems, never expose in logs or client-side code. Yes, correct. Okay.
Just explaining what you understand from each and every point.
Yeah, see now secrets. First of all, whatever secrets are storing, the data or anything, that should be encrypted so that even somebody takes it, it is in encrypted form, so he can't decode, decrypt, and then get in. So it should be always encrypted, and then rotated means it should be like two, three people are there. or yeah, I mean, it should keep the say that authentication or whatever it is, that should get rotated on maybe daily basis or weekly basis, something like that. So they don't use the same thing again and again. So it should have a rotation method. Then stored in secret management system. I think in a server you have to store the secrets. There's a facility where you can store it safely without any compromise on that. They never exposed in logs. Yes, this information should never ever come into the log files, because I have read somewhere you generally people go through our log files and take a lot of information from that. So now the log should not contain any of this information for them to get in.
Yes. Even means some means by mistake, if you send your secrets on
Uh,
push your secret on
to
GitHub,
the
GitHub scanner also identify that and warn you.
uh,
If you shared your this Google key,
uh,
OpenAI key, or some keys,
uh,
then it will warn you. Okay,
yes.
and whatever you are talking about, the stored in a secret management system, that's a
Uh,
your this key vault. Key vault is, you can say, store your things,
uh,
and when you require, it will provide you. You
yeah.
need to link, and it will provide at a runtime.
Right.
Okay, go ahead, please.
Example, a delivery is absence and access token. Backend verifies it, correct? Token is right, token is real, token is not expired, so it is still within the time limits. Token belongs to delivery user, verified. Token was issued by trusted identity provider. Only then should the request proceed. Correct, perfect. How to implement, yeah, into authorization correctly. Separate identity from separate identity from permissions. Okay, authentication proves who the caller is. Authorization checks what the caller is allowed to do. Right, got it. So somebody is logged in, so when they're trying to log in, i I authenticate him whether he's valid user or not. Once he logs in, then their next level is, for example, that person should not have access to my, say, for financial module or some inventory control module. So there are some restrictions for him. And also, let's say financial module, he has the permission, the authorization to do, but he can only view it. He can't go and modify like that. The other levels of control can be built. So authentication is separate, authorization is separate.
Yes,
Fine. Never treat you so. Different roles. Yeah, exactly. Customer can view own order. Correct. Perfectly. Delivery partner can update assign deliveries. So yeah, restaurant can update food preparation status. Admin can manage support action. Analytics job can read aggregated data only. Right. There's no mix up here. Payment services can't go and update the order service. Order service can't go and update the payment service. So everything clearly defined. Boundaries are really set. Different
so
roles. Yes. Yes. Go ahead.
earlier means we discussed about this means in our authorization itself, we have a different way to authorize, am I right?
Ah. 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 Ah.
So could you tell me about those if you're able to recall?
Okay.
RBAC is there, role-based access control is one.
Role-based access control, RBC. Okay. RBAC. Okay.
Yes, RBAC, and apart from RBAC,
Okay. Uh, Role-based fine-grained control. I don't know whether that falls under this category. 1 minute. So one is RBAC. The other one is uh, authorization is role-based, correct? Then 1 minute. One thing that they use one keyword. Mm, One is RBAC. RBAC is mere thing. That is where we authorize role based. That is role based. Okay. Uh,
attribute based.
okay. 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 Fine.
where we will give a attribute. Hey,
Uh-huh.
this is you can say I can do this thing and work on this attribute. So we can give access
Right.
authorized for those only.
Right. Then maybe one more thing I think you use access control list. Something you gave that day. And one more thing can be like policy based access control, right? Policy based
Yes,
control.
yes, yes,
Yes.
yes, yes.
Uh,
Where we will define the policy.
yes. Yes. Okay. Right. Then info, sorry, check ownership and scope. Yeah. Okay. Check ownership and scope. Yeah. The user may have the right role, but still not have access to every resource. Okay, perfect. A customer can see their order, but not all orders. Okay, beautiful. A delivery partner can update the assigned order, but not every delivery. Correct. A support user may view unmasked data. A support user may view masked data, not full sensitive data. Okay, fine. Okay, fine. Okay. This is like if I go to ATM, I can draw only my amount. I can't draw others' amount.
Yes.
Okay.
A sport user cannot see all the information. They will see,
Uh,
let's say, first letter of the your
uh,
card,
yes.
second
Correct. Yeah.
last letter of the
Yeah.
card. They are not able to see this full
Full card. Yes. Correct.
information.
Yes. Fine. Prefer least privilege. Grant only the minimum permissions required for the task. Grant only the minimum permission, right? Example, a delivery partner is authenticated successfully, but authorization must still check, is this order assigned to this partner? Is the requested status transition allowed? Is this action allowed at this stage? Yeah, like after is authenticated, further checks. We should authorize him for further. So yes, correct, right.
Okay.
Yes, okay, got it.
Means, but here you need to think
Ah,
these points. Means here each as per my understanding,
ah,
here we each and every step we need to check. Something
check.
is pending.
Yes.
We need to ask this question. Something
Ah,
is pending. We
ah,
can go
ah,
forward or not. If we can,
ah,
you can say go forward. Then we need to think about that as well.
ah, ah, ah,
If
ah,
we are not going forward, that means we are good.
ah.
So you need to train your mind in this manner.
Right.
Something is left. Yes,
Mm.
then you need to think about that as well.
Ah,
If
okay.
something is not left, then you're good.
Mm.
Means I'm saying you need to train your mind in this manner.
In this manner, correct, correct, correct. Right. How to apply least privilege system design? Beautiful. List every actor. Actors include end users, support users, admins, services, schedulers, background jobs, okay, external integration, API calls. Correct. So list every actor. How to apply least privilege in system design. Okay, fine. List out every actor. Okay. Then define minimum required access. For each actor, list only what is needed. Okay. For example, end user can only place the orders. He can't go beyond that. You can place the orders and then he can do the payment. Beyond that, you should not be able to do anything. Yes. Support user, for example, one is authorized to create the product list. He can only create the products. He can't go and tamper with the payments. Right. Okay. Got it. Uh, the example notifications are which are read template data, consume order events, send notification. Right. That's all. That is the only role you can play. Okay. Not needed to update orders. Yeah, state, read full payment detail, change user profile. Yeah, perfect. He can't. Then restrict data visibility. Do not expose all fields just because the service or user is authenticated. Okay. All right. Yes. Don't show all the information. What is display only the required information, but not all. Yes. Use separate identities for separate functions. Do not use one powerful credential for many services or environments. Okay. So
Hold on, hold on. Let's
ah,
discuss
ah,
on this how you can achieve that.
do not expose all fields just because the service or user. If, for example, for delivery purpose, I need to expose only the address details. I need not display any other rest of the information of the user. The delivery partner is supposed to deliver the goods. So to him, show only the address part of it. In my profile may contain hundreds of information, hundreds of details. Don't show all which is irrelevant to that person or module. Delivery is to deliver the goods where to an address. Show only that. Or if you say payment, now I need to know whether I paid or not. So whatever amount I paid, maybe in display this amount is received, rather than going into my earlier payments and displaying all the history of my payment. Not required. For him, he should know whether payment is made or not. So only that part is made visible to the person. So that is example of restrict data
But
visibility. Now,
how? I'm asking how. I understand your API is sending all the information, am I right?
huh,
But you
huh,
are willing for some of the information.
yes.
How you will do that? How you will give a, you can say, flexibility to the user so that he is able to get that information only. Means your API should be capable to do that.
See, therefore, my delivery API is designed such a way that that it should expose only the address part of it.
How means, let's say your delivery, in a delivery, if you talk about that, in a delivery lot of things are matter, am I right? And it's applicable for your vendor, delivery partner, as well as that delivery boy, am I right?
Huh, huh, huh.
And your customer as well. Means you will create multiple APIs on how you will manage that, so that every user will get a required information. It will not get all the information or unnecessary information. For that, how you will do that? My question is that.
Okay, 1 minute. So,
You understand
uh,
my point?
okay. Now let us say we have one common API. In the example of this, what we're discussing now, address the delivery part. Yeah, it can be to example. I may deliver to a vendor. I may deliver to a customer. Yeah, there are different deliveries. So well, let's say we have a common API. So now uh, I have received an order. Payment is made. So now I need to deliver that item to the customer. So the API should know that, okay, so this call is coming from the orders services asking me to deliver an item to so and so person or address. So the only the address of the customer I am going to expose. The same API, when it comes to, say, calling, I may reach out to some vendor for something. So now it should understand that the need is for a vendor-based thing. So only the vendor-related, for example, one vendor may supply 5 items. So only related to that vendor, you display the required items. So not all. So one common API will understand from where the call has come. Based on the call and the type of the call, it should bring up the required information alone. So
So
in a way,
you just go ahead. Go ahead.
I'm trying to understand from where the call has come, whatever call has come, and what to expose very clearly is very clearly defined while designing an API. Based on that, things get exposed.
Yes, based on that, you can say, based on that you will tell the front end person, hey, you need to send the form in this manner, and or build
Ha, ha,
create a request in this manner, and
ha,
whatever
ha,
your checkpoint like type, user type, or but
yes.
based on that you will need to apply a check as well
Ha, ha,
on
ha.
your side. Am I
Right,
right?
right.
So both should be agree on that
Right.
contract. Am I right?
Mm. Yes.
Otherwise, the front end will not send the required information. You are not
Mm.
able to do that.
Right.
And another point is this means, we have a REST API and GraphQL.
Yes.
So what is GraphQL?
GraphQL, I didn't read them, but I may read briefly about REST API, where it will allow you to allow you interact with different services like client services, server services, all that. GraphQL, don't know, Deepak. I came across that word, but I don't know. I didn't read about it fully.
So GraphQL,
Ah,
this is a, you can say, ecosystem. With the help of that, you can give a flexibility in a REST, but we will do each and every resource have their own endpoint.
ah,
Like product have their own endpoint, user have their own, admin have their own, or
okay.
product have their own endpoint. Am I right?
Ah,
And you can say based on that endpoint, we will interact with the data resource. Okay,
mm.
and means CRUD operation, we need to go with this different things, and
Mm.
means based on a same for that particular a resource only, we have a different operations,
Ah, ah, ah,
and
ah.
requests are there, and based on a request different response are there. Am I right?
Mm.
But
Yes, yes.
sometime if you, let's say, in that case, if you are means either you need to apply lot of checks so that you can serve
Ah,
a different data to the user. Am I right?
ah, 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 ah.
Or you need to means user will get all the data, even though
Mm.
it's required two field, three field to display
Mm.
on the UI, but you will send all the field.
Ah, ah, ah.
So okay, it's the same kind of thing. Means user don't have a option to order by himself because he don't have a menu or this thing.
Ah,
So
ah.
whatever restaurant is serving, he don't have a choice. Am I right?
Okay, 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 okay.
But in a GraphQL, as its name suggests, GraphQL
Ah, ah, you,
means yes. So in this, you can decide. Client can decide, hey, I require this data only.
okay,
Okay, in this
okay.
manner, from
Ah,
a same endpoint, you can get different data as per your requirement.
okay, 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 okay,
Okay,
okay, okay,
so this is a
okay.
GraphQL. So
Ah,
in that, you can user front end can you can say calling user can do this.
okay,
Okay,
okay, okay.
okay,
Right.
go ahead.
Separately identity for separate functions. Okay, do not use one powerful credential for many services or environments. Yes, each service, for example, should have different credentials. If you, because let's say no simple, you take one password we have. I have a password for my Gmail account. I have a password for my ATM operations. I have a password for net banking. So now there, what I do, or even for my laptop to get into the system also, there's a password. Now, if I have one password for all this, if by any chance, if that password is compromised, gone, everything will be hacked because I don't have different this one passwords for different applications. So I kept one thinking that okay, it'll be easy to remember, very easy to, so any to any application I go, I know the password very easily. Yes, ease of use is nice, but if it is compromised, your entire data in all the levels can be hacked. So to avoid that, you give different credentials for different services. So if one is compromised, only that part is getting affected. For example, Gmail access is compromised. Okay, only your mail, Gmails will get compromised. The rest of the your banking credentials, laptop, all will remain same.
Yes.
So you are not
Now,
giving full power to the person with just one credential. You are having different credentials. So only one part may get disabled, I mean suffer. The rest will be safe.
yes,
Okay. So how to protect data at rest? Identify service sensitive data. Example, personal details, phone number, addresses, payment reference, identity, document, access token, internal operation. 1 minute. How to protect data at rest? How to protect the data? First step, identify sensitive data. Yes, identified now. Personal data, all this identified. Then store sensitive data with encryption. Yes, perfect. Fine. Then other one is storing in the secrets management. Your product data in databases, file storage, object storage, backups, logs where necessary. Yes. Limit who can read it. Encryption alone is not enough. Oh, okay, okay. Access control will restrict who can read the decrypted data also. Oh, okay, fine, okay, fine. So that means once I decrypt the data, if I, oh, sorry, once I encrypt the data, if I want to decrypt authentication, Deepak, there, I no, now if you want to decrypt it, again there is one level of verification authorization done.
Definitely means because that time even though you are applying it encrypted decryption, am I right? But if you will give access to the wrong
Ah,
user,
ah, ah,
he is able to get that data. So
ah,
that's also a blunder.
ah, ah, okay, 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 okay,
You understand my point?
okay,
Which
fine.
we discussed
Okay, okay,
already,
okay.
means you cannot trust.
Ah, correct, correct, correct. Yeah, yes, 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 right, right, right. Okay, okay. Fine. Avoid storing what you do not need. The less sensitive data you keep, the less you must protect. Yes, correct. Right. Protect backups too. Yeah, another important thing. A secure production database with insecure backups is still an insecure system. Exactly. In food delivery platform, customer addresses are encrypted in storage. Full payment card data is not stored directly if payment provider tokenization is used. Support tools. Support tools show masked personal details unless elevated permission is granted. Okay, okay, okay. Okay. Right. How to protect in transit? Yeah, again. Okay, use HTTPS, most important. Yes, and HTTPS, ILT, TLS. Okay, mobile app to backend, browser to backend, partner system integration, admin portal access to encrypt all external communications. Right. Okay. Then encrypt internal communications too. Internal service to service traffic must also be protected. Okay. Right. Verify endpoint identity. Encryption alone is not enough again. Oh my God. Systems must also verify they are talking to correct service. Okay. Prevent downgrades. Do not fall back to insecure protocols. Okay. Okay. Fine. Handle certificates properly. Yeah. Certificate life cycle must include trusted issuance, renewal, rotation, expiry monitoring. Okay. Fine. Example, order service calling the payment service should include, okay, use TLS, verify payment service certificate or trusted identity, reject insecure or untrusted connections. Yes, perfect. How to secure service to service, give each service an identity. Each service should have its own verifiable identity, right? Authenticate every internal call. Do not accept internal request just because they come from a known network. Okay, fine, right. Authorized service actions too. One service may be unauthenticated, but still should not access every internal API. Right, API. Sorry, right, right. Limit scope of service permission. Delivery service may read delivery relevant order fields, right? Notification service may consume every data, consume even data only, correct? Analytics pipeline may read aggregate data or pro database, right? Log internal access. Internal call should be traceable for debugging and incident investigation. Example, it is truly a delivery service, full delivery service is allowed to read assigned order status. It is not allowed to update payment information. Perfect. Perfect. How to design secure API. Authenticate the caller. Every protected API should first verify identity, authorize the operation, check whether caller can perform this on this resource. Fine. Okay. One small question is coming, Deepak. For example, when we do this many things, no, uh, somewhere will the performance be slightly affected? Like we are looking at the trade-offs, right? So for me, data is important, so I don't mind it delaying the process, right?
Yes, definitely.
Okay, okay, that's a
You are
trade-off.
applying, you can say this checks there, each and every point you
Ah,
are applying a check. That's
ah.
definitely performance will be hit there.
Affected. Okay, okay. Fine. Okay. Got it. So authorize operation. Check whether the caller can perform this operation or on this other. Okay. Validate all inputs. Okay. Validation missing required field, type mismatches, illegal values, invalid state transition, Okay, this is all nothing but validations. Okay, OS the payloads, malfunction identifiers. Okay, fine, right. Limit abuse. Use protection such as rate limiting, yeah, throttling, payload size limit, safe retires. Okay, then timeout controls. Yes. Okay. Right. Return safe errors. Yeah. Error responses should help legitimate clients without exposing internal secrets. Error responses should help legitimate clients without exposing internal secrets. Bad. Database table name, stack traces, internal host names, secret values. Good. Structured error code. Safe human readable message. Trace or request ID. Okay. Right.
So normally developer do this. They will just
Ah,
think means we are means they will use trace logs,
ah, ah,
logs while developing this. This
ah.
is not a good practice because we are
Yeah, correct.
developing for end user. Am I right?
Ah, ah, ah,
We are
ah,
not
ah.
developing means end user, not a developer. Am I right?
Yes,
We
yes,
require meaningful information.
yes, correct.
And this traceful trace this means if you it will contain like mean neo4j database information or query information.
Ah,
They know means what is
yes,
happening there. So
yes.
rather than doing that, we need to give a
Ah,
meaningful message to the user.
right,
And
right.
messages are not generic. It should be a meaningful.
Meaningful one, correct. Right. Audit important operations is log high risk actions such as login attempts, yeah, permission changes, admin operations, payment related actions, data export request. Ah, okay, fine. Yeah, it should be audited. Okay, fine. Right. Example, a secure order cancel API checks who is calling, whether caller wants the order support, whether caller order can still be cancelled, whether request is valid, whether rate limit is respected. Okay, so you do all this auditing. Fine. Okay. How to protect sensitive data? Expose only necessary data, or like we expose example, address example we give. Do not send full user data everywhere. Correct. Only what is required you send. Then mask sensitive fields. Yeah, for example, credit card number, passwords, then raw tokens, payment secrets, full personal identifiers. Yes, mask them. Okay, correct. Use tokenization or indirection where needed. Instead of passing raw sensitive info values, use references or tokens where possible. Here, many times I'm coming across tokens, Deepak. For example, if I want to pass, say, employee ID or my current balance to something. So can you just give me like how this token works?
Like tokens are means you can say right now you are sending me a Hindi, and
Ah,
rather than taking that simple English means Hindi, I am just swap with the some pattern. I will make it something else.
okay.
The user is not able to see what
Ah,
I am
ah,
sending.
ah,
But means whatever you swap the end where we are sending data, they know
ah,
how
ah,
what is the meaning of this
ah,
content.
ah, 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 ah,
And after applying that pattern or thing, they will understand what user said.
ah, ah,
So
ah.
normally tokenization is used in a FinCorp company.
Okay, 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 okay. Fine. Okay, use organization or in there. Okay, fine. Restrict admin and support view. Operational tools should show only the minimum needed data. Okay, fine. Right. Restrict. Audit access to sensitive information. Right. Sensitive data access should be visible and reviewable. Okay, fine. Right. Right. Okay. How to build security into architecture? This is very important. Right from day one, add security to architecture diagrams. Okay, fine. Add, okay, fine. How? Okay, show trust boundaries, identity checks, authorization points, encryption paths. Okay, okay. Then secret storage, audit logging in locations. Okay, fine, right. Beautiful. Then make security a design decision, not a patch. For every new component, ask who can call it. Okay, okay. Come down, please. Okay. Okay, who can call it? What data does it handle? What trust boundaries does it cross? What happens if it is abused? How is access limited? Oh, okay, fine. Everything should be defined. Oh my God. Standardized security control. Use common patterns for identification, identity verification, permission checks, then secret management, service authentication, audit logging. Oh, okay, fine. Design for compromise containment. Assume one account, one token, or one service may be compromised. Yeah, limit blast radius. Okay, example you gave yesterday. Also. Okay, friend, got it. Okay, keep security observable. Task, fail login attempts, very important. Suspicious access patterns. Okay, token misuse, unusual admin behavior, repeated authorization failures. Okay, then step by step. And okay, fine. Scenario: delivery partner update status of assigned order. Delivery absence request. Request includes access token, order ready, new status, request metadata. Now, API gateway verify identity, checks token validity, expiry, issuer, service policy if applicable. Yes. Third step, backend validates payload. Yeah. Order ID format, allow status values, request completeness. Authorization checks. Verify caller is a delivery partner, order is assigned to this partner, request transition is allowed. Fine. Request transition is allowed. Fine. Secure service communications continues. If order service needs delivery service confirmation, that internal call is authenticated and encrypted. Yeah, fine. Okay. Update is written safely. State change is recorded with actor identity. Yeah, who is that? All the identity. We identify that person. Okay. Then time stamping. Okay. At what time this thing took place? Okay, fine. Okay. Time stamping. You have to come down. Then previous, okay, what was the previous state? Okay, what is the new state? Okay, one track the trace ID. Okay, fine. Audit trail is stored. System logs are the change for later investigation and compliance. Yes, correct. Response returned safely. Client gets a clean response without sensitive internal details. Beautiful. Okay, this is a visual part. Fine. Okay, okay. Beautiful. Okay. Okay, which is service to service flow. Okay. And then data protection layers. Okay, different data protection layers in a digital form. Okay, fine, right. Visual form. Okay. Sensitive data, encrypted data, encrypted transit, restricted access, masks, mask and logs. Okay. Then auditing the okay, and then audit access. Okay, fine, right. Beautiful. Common engineering mistake, trusting the client too much, mixing authentication and authorization, giving overpowered service accounts, ignoring internal security, logging sensitive data, encrypting storage but not access, or storage but not access, no audit trail, exposing too much data in API. Okay, fine. Okay. So many things are there, Deepak, when you go, my God, too much. Okay. But in fact, I want to see one in live action, like so many points we read, no? Like right from day one, it has to be implemented. So we need to see one good live example where they clearly define